Okay, so today we're going to be fooling around with geometric sequences. All right, in a geometric sequence, we have G1, G2, G3, G4, and to make G2 out of G1, we multiply it by a constant, and that constant is a ratio, okay? And it is a constant ratio where R is equal to Gn plus 1 all over G sub n. So I can find I can find the ratio of terms by just dividing two next door neighbors. Okay, so let's kind of build this up a little bit. So let's take, for example, an easy one here. Let's take 3 and then 6 and then 12. What's my next term?
24.
How'd you get it?
Multiplied by 2.
How did you know to multiply by 2?
6 divided by 3.
Okay. Yeah, you took these and you divided them and came up with 2. Or you could have taken these two and divided by 2 also, right? It would have still worked, right? Any term you would have picked and then just divide it by the guy before it, and you're going to get that ratio. So now, in order for me to get my fourth term, I have to use 3 2's, don't I? So what if I wanted to ask you what the 90th term would be? How would you find that? How many 2's are you going to use in order to get to the 90th term?
89.
Why 89?
Just because it's always one less. Because you have your starting term.
Yeah, I don't need a 2 to make this guy, but I need a 2 to make him, and a 2 to make him, and a 2 to make him. So for the fourth term, it was G1 times 2, and I needed 3 of them, right? So for this guy, for G sub n, in order to get the G sub nth term, I need the first geometric term, this guy, times my ratio, whatever that is. And just like we saw before, to get the fourth term, I need 1 less. So to get the 90th term, I need 1 less. And in general, we can write it that way. And this is the formula for the nth term of a geometric sequence.
Does this formula go on our sheet then?
Yeah, in that grid.
Yeah.
Goes right
Okay,
there.
thank you.
Okay. So let's use the formula, let's use this formula to come up with, and the sequence that we had before. Let me get some more paper, sorry. So we had 3, 6, 12, 24, ... Now, what I want is to be able to write a formula in 2 different ways for this. Let's do the one that probably is the most intuitively obvious, which is a recursive. Now, what I want to say is, for the nth term of a geometric sequence, how do I get that next term? Like, how would I get 48 right here? If I was going down the line, how do I get 48, which is sitting right here?
You'd multiply 24 by 2, which would be the 5th term.
Right. So if I wanted to write that as a formula, what I'm saying is that whatever term I'm on, it's equal to the term before it times 2. How do I write that?
N minus 1 times R.
Okay, now n minus 1 has got to be a subscript, right? Because it's the term before it. And this is for this sequence, so I'm going to use 2. Okay? Now, the explicit for the explicit formula, you use the formula that we got before. Okay? So that is G sub n is equal to, now the formula was G sub 1 times R to the n minus 1. So this is 3 times 2 to the n minus 1. This is your explicit formula. Now, I will say that for some of these, there's an alternate way of writing this, which sometimes is a little bit cleaner. Let me just give you a different formula so that you can kind of see what I'm talking about. Let's do this formula. 6, 18, 54. Okay. So what's my, well, this is my G1. That's not very exciting, right? But what's my R?
3.
Okay. So R is equal to 3. So now my G sub n is going to be my first term, G1, times my ratio to the n minus 1. Now, the only thing that I'd like to just point out here is that we can clean this up. First of all, this is not equal to 18 to the n minus 1. Remember, our order of operations tells me exponentials have to happen first and then do multiplication. So I can't make this 18 to the n minus 1. 6 times 3 to the n times 3 to negative 1. Or you can just jump to this. So just be aware that, sometimes you might be able to get rid of the negative exponential and just clean it up a little bit. Okay, that's an alternate form. And let's check it out. When n is 1, it's 2 times 3, which is 6. And when n is 2, it's 9 times 2, which is 18. You see? So it's just an alternate way of writing the explicit form of your answer. Okay. All right.
Mr. Ronco.
Where you at?
Where it says 6 times 3 to the power n divided by 3, why isn't it 2 times 1 to the power of n? Why don't you divide 3 by 3?
This?
Yeah.
I can't because this is an exponential. So let's think about it like this. If I have, let's do this way. 5 squared divided by 5 is not equal to 1 squared. See what I mean? I can't cancel those out. Doesn't work. Because this guy has the order of operations tells me I have to do this operation first. So 5 squared over 5 first has to become 25, and then it can be reduced to 5, which is 5 to the first. And really all you're doing is subtracting an exponent at that point. So those are your exponent bits, exponent rules.
Okay.
Cool. Now, all right, let's do some problems. I got problems. I hear you in the back of your mind. You don't have to repeat that. Okay. So let's find a formula. So 12, 6, 3, 3/2. Find a explicit formula and make it pretty. One second. Okay, so this is my G1, and what's my R?
Okay.
Hmm?
1/2.
1/2.
Is it 1/2? Yeah.
Okay, so G sub n is 12 times 1/2 to the n minus 1, right? Now, let's see if we can clean this up to try and make it look just a little bit better. So 12 times 2 to the negative n plus 1. You could write it like that. That's one way of writing it. Another way of writing it is realizing that this is 3 times 2 to the third. You could write it like that. Wait, that's a negative n. Wait. When n is 1, it's 2. So this formula works. That's a 3. Yeah, this works. Because when n is 1, then I have 3 all over 2 to the negative 2, which is 3 times 2 squared, which is 3 times 4, which is 12. So it works. There are different ways of writing your answer. That's what I want to get you to, okay? Because you've got that negative 1 exponent in there, and you might be able to rearrange a little bit, okay? If you're not sure, just plug it in and check. Okay. All right. Let's do, ooh, that's a good one. Don't lose that negative sign. That negative 2 has to be wrapped in parentheses. Okay? Every single time it flips sign, every time you see something flipping sign, you're going to be dealing with something negative inside an exponential, toggling back and forth. Okay. Okay, let's get into something a little bit more, a little more meat on the bone. This one's a little tougher. Okay, so what's my R?
Two-thirds.
Okay. And obviously 3 is my G1. So I don't know how many terms there are, right? But I do know that 128 over 729 is made using that formula for whatever n is. So at this point, we're going to invoke not our calculators, but we're going to invoke what is called the fundamental theorem of arithmetic. The fundamental theorem of arithmetic means that I can take any number, any natural number bigger than 2, or 2 or bigger, and I can break it down into a product of primes. So off to the side, (128), 2 and 64, 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. 1, 2, 3, 4, 5, 6, 7. Three and 1, 4, 3. No, wait, 2, 4, 3. 3 and 81, 3 and 27, 3 and 9, 3 and 3. 1, 2, 3, 4, 5, 6. Okay. Now, what's great is that the answer almost pops out by itself. Divide this 3 over here. Now they both have a power of 7. So that tells me that n minus 1 has to equal 7. So n is 8. Use the prime factorization. It's a very, very, very useful tool. It will pop up again and again. Okay. Emma, that's a crinkled brow that would crack granite. What's your question?
I just don't understand how like the 2 to the 7th over 3 to the 6th went from that to the answer.
Okay. Give me a second. I'll work it out. Hold on. 2 to 7, 3 to the 6th, 3 times thing. I'm just going to call it thing. I don't really care about it, right? It's just a thing. Now I'm going to multiply both sides by 1/3, or basically divide both sides by 3. And now that goes away and I just have thing, okay? And now by the exponential rules, I add my exponents and I get 2 to the 7th over 3 to the 7th. And that is the same thing as saying 2 over 3 to the 7th. Because if you remember those exponent rules, when you have a power to a power, right, these are to the first, it multiplies in. And that's why it's 2 to the 7th and 3 to the 7th. So you can do that.
Okay.
Cool deal. Yeah, that one had some meat on the bone. It's good. I like that problem. Don't worry, you'll have more of those. Okay, which one did I say? Okay, now this one you might need a calculator for. That's a 6.
Mr. Ronco,
Speak to me.
quick question. The second term, is that a 4 or a 9?
That's a 4.
Okay.
Sorry, I don't have good markers. They dull so darn quickly, man. They come out sharp and then like a block later, they're like, I might as well be using a pool cue. Okay, so first things first, people, let's set this thing up. So the nth term, whatever that term is, there's some term that's smaller than this number. Okay, so I want my g sub n to be less than 10 to the negative 6th. And this g sub n is equal to my first term times my r, and my r is just the same thing. But it's to the negative 1. Wait, hold on. Oh, I lost somebody. Give me a second. All right, actually, I'm gonna rewrite that so that it's a little clearer. I'm just gonna do it over here, okay? So I'm gonna do this over here because I'm gonna run out of room. So 10 to the negative 6 is g sub n, which is g sub 1 times 2/5 to the n minus 1. Now, I could have just gone right to this because the nth term is this. And if you look at this carefully, you'll see that this just turns into 2 over 5 to the nth, which is this. So what we're looking for is we're looking for this guy less than that guy. So I have 2 over 5 to the n is less than 10 to the negative 6th. Now, here's the thing. Kids screw up inequality signs all the time. All the time. So here's what we're going to do. We're going to lie. We're going to cheat. And the reason why we're going to lie is because when we get our answer, which is going to be some cracked out decimal, then we're going to decide, do we round up or do we round down? But if we keep the inequality sign in there, chances are some of you are going to screw that up. And the reason why is because I don't know how strong you guys are with logarithms, but logarithms of numbers less than 1 are negative. And in a minute, we're going to have to divide by a logarithm. And if you didn't know that, you're going to not flip your inequality sign and you're going to get it wrong. So that's why I'm saying just make it equal. And then at the end of the day, figure out, do I round up or do I round down? Okay, don't try and hold on to it in the middle of the problem. Too many problems. So now, in order for me to get my n down, I have to use a log. You guys remember how to do your logs? Oh, sweet Christmas. Are you telling me seriously? Does anyone know how to do logs? Didn't you do logs last year?
Yeah, but no. It's kind of back in my brain. I can't really remember.
Dude. Bummer. Okay. Take a log both sides. Exponentials become multiplication. And log base 10 of 10 is 1. Now, you go to your calculator and you put that sucker in the calculator and you come up with some cracked out decimal. Now, do not freak out that you've got a negative here, because the log of a number smaller than 1 is negative also. So you get a negative over a negative, and we want a positive n because a negative n doesn't make sense. What does this turn out to be? Somebody give me an answer in decimals.
15.1.
15.1
if you round.
0.1, okay, all right. So the thing of it is that if I have a term that is exactly at 15.1, at 15.1, I will be exactly at 10 to the negative 6th. What I want is to be smaller than 10 to the negative 6th. So let me ask you, if I went to 15, let's do them bigger and smaller, 16 and 15, will the 15th term be smaller than 10 to the negative sixth? Or will the 16th term be smaller than negative sixth? Here's how you tell. Look at your sequence. Is my sequence getting bigger or is my sequence getting smaller?
Smaller.
Yeah. So if we were to actually think about that graph for a moment, it would look something like that. And at some point, we are below, and I shouldn't have made it hit, but whatever, my artwork sucks. After a certain point, this before that point on the 15th term, it's still too big. After this point, it's now smaller than that. So that means we're going to round up, even though it's 15.1, we're going to round up to 16 so that we get below the threshold. Okay, so there is, hold on.
Wait, so if it was increasing, you'd round down?
Well, it depends on what the problem was. Okay, but you need to understand what it's looking at. So like, for example, if I had a sequence that was increasing like this, and my threshold was here, the question is, it always depends upon the question. The one that's before it crosses the threshold or just after it crosses the threshold? And that's why it was important to, read the question carefully, because in the question, as they said, they want the one that is smaller than the threshold. So that means we're going to be going beyond, and that's where the threshold would be if you were thinking about that curve. This one would be the one below the threshold. But if they said, you can't cross the threshold, you have to be, it can't be, like if it said is not smaller than 10 to the negative sixth, then you would pick this one because he's still bigger than 10 to the negative sixth. Does that make sense?
Yeah.
It all depends upon the question and what they're asking you. Okay. So we are just now out of time. And I'm posting your next assignment. All right. All right. So if anybody has any questions, you can stick around, but I am right now writing the post, the announcement that will contain your next homework assignment. Right. So is everyone cool? All right. It's not that bad. It's here, I'll show it to you. It's really easy. Here, I'll share my screen so you can see it. You'll see it in a second anyway. So these are just kind of like, find the nth term. Find the nth term, how many terms are in the sequence, how many terms are needed to get within, so below 10 to the negative ninth, and then a couple of ones to make you think.
Is that due next class with the other homework?
I know. That's what happens when I stagger homeworks. Okay, 2 homeworks. It's due in 2 days. 2 classes, so 1 week. Due in 1 week, okay?
Okay. Okay.
Come to class next time with questions about this one and your old and your other. See, this is what I've done in years past, is that I'm always staggering the homeworks, 2 days apart, so that people come in and ask questions.
Yeah. Okay.
One is due and one is reviewed. One is due and one is reviewed. Are we good?
Yep.
All right. If you're cool, I will see you all later. If not, stick around and we can talk.
Have a good day.
You too.
Thank you.
Yeah,
Thank you.
See ya.
Have a good day.
you too.
Thank you.
Thanks.
Mr. Rongo.
So,
Hey, so it was about the homework. I just didn't want to bring it up at the moment, but
yeah, okay.
you know, you said like keep it accurate to how you solved it and all.
Wait, say that again?
You said keep it accurate how you solved it, so you can go back and like help us with stuff, right? In terms of
Okay.
solving the equation.
Yeah, it's not just about solving. It's not just about getting the answer.
Yeah, it was the work and all, but like for number 2, I did that completely in my head in like 30 seconds.
Doesn't
So do
matter.
I? Yeah, so do I have to write that down still
Yeah,
though?
you do because I don't know. First of all, let's just say I don't know you from Adam, right? You know, we never met. You're
Mm-hmm.
one face in 100 kids in a classroom in an auditorium,
Yeah.
right? Which is what college will look like. Then what's going to happen is I'm not going to know if you got it in your head or if you borrowed it from your neighbor.
Yeah, because if I just write down the answers, that doesn't show the process.
Right. It's about communication. So it's kind of like, you know, if you say to me, if you just stick your head in my room and say, hey, the answer is 4, well, how the heck did you get it? You know?
Yeah.
So a lot of it is about telling the story, even if it's redundant. And I mean, like, let's be honest. Yeah, I'm a teacher and I do this stuff every day. But if I was doing this problem, I could jump through 6 of the, I could skip like 4 or 5 steps and just jump to that or even something simpler and get an answer. But that wouldn't help you.
Yeah.
You know what I mean? Like, so my job is to communicate, and so is yours. Yours is to communicate with me about how you did it.
All right.
Cool. Even if it's silly.
And then
Yeah.
also so with the I emailed you back with the organization, but I never really got taught how to like specifically format quote unquote like the work. So I was just wondering if there's a way you liked it to be.
Not necessarily, as long as, and that's kind of up to the author, but some things that all problems should have are, it should say what problem number. If it's a long drawn out problem that involves like, lots of stuff, you don't have to rewrite the problem, but it's always a good idea to say like, kind of like the nuts and bolts of the problem. So like if there's important, like always write your formula down.
Yeah.
Okay. So if you're going to use a formula, like for example, if I had to do, find the line through origin with a slope of -2. Okay. Now, I know and you know that the answer is y equals -2x. But I'm going to do this. Because that's the formula that I'm going to use. And I might even just say this. I'm listing my known information, I'm listing my formula, and then I'm executing it.
Yeah, so what you do, so like I should just kind of like, I notice like you always, after you write down the initial formulas and all, or like the information you have, you throw in the formula. So should I just do like available information, formulas, and that's like my explanation, and I can just plug everything in
and then roll
it.
through it. Right, exactly. So, now you've got, and that's your answer, and you box or circle it.
Yeah. All right. So just kind of stagger it. So available information, formulas I'm going to be using, and then plugging that information into the formulas. All right.
Exactly. And you see, the thing of it is that if you didn't include this, and you didn't include these, and all you put on the paper was this guy, how do I know you know how to do it?
Yeah.
All I know is that you wrote the right answer down. You could have taken that from anywhere.
Yeah, that makes sense.
You could have used the calculator if you didn't know what you were doing. You could have used your neighbor, your uncle, whoever. You know what I mean? So that's why we have to kind of lead the reader through the work.
And then sorry for bugging you with more
No,
questions.
you're good.
My internet cut out right
Oh.
when you were going to where the homework was. So where's the homework at?
I'm
homework?
posting it right now on
All right.
campus.
All right, thank you.
Yeah, I'll post it in like 30 seconds.
All right, have a nice day.
You too, buddy. Take it easy.